The ultimate endgame of cryptocurrency is to replace the corrupt and inefficient financial systems we have today. So far, we've seen amazing progress towards this goal. Decentralized payments, saving, lending, borrowing, and even stock investing can be done directly peer-to-peer without a middleman and without KYC documentation. The decentralized applications that provide these services collectively hold over $100 billion in cryptocurrency, and their TVL continues to grow by the day. There's just one thing that's holding cryptocurrency back from true mainstream adoption, and that is speed. Most cryptocurrencies are just too slow to support the billions of transactions made by billions of people every day. Even though lots of cryptocurrency projects have made a habit of bragging about how many transactions per second they can handle, the numbers they provide rarely stand up to scrutiny. That's why today I'm going to reveal which cryptocurrencies are really the fastest and why. Hold that thought, I need to make sure I'm not at fault. Nothing in this video is financial instruction. This is purely an educational production. If you're new to the Coin Bureau, my name is Guy, and here's what you should know. This channel is home to some of the highest quality crypto content on the internet. Coins, tokens, news, and reviews. Videos so good that if you're not careful, you'll wonder where your day went. If you're looking to make serious gains with your own brain, subscribe to the channel and ping that notification bell to get your head in the crypto game. Time is money, which is why I've left timestamps in the video timeline, which you can use to skip around if you're in a hurry. If you watch the video the whole way through, it will increase the chances that this video shows up in the recommendations for someone like you. Now that you're all set, let's see how fast cryptocurrencies can actually get. Unless you're completely new to cryptocurrency, you've probably heard of the Blockchain Trilemma. The Blockchain Trilemma was conceptualized by Ethereum founder Vitalik Buterin in 2016, and it states that a cryptocurrency can only be two of the following three things: scalable, decentralized, and/or secure. Now, scalability refers to a cryptocurrency's ability to maintain its performance even with millions of users and transactions. For the purposes of this video, let's just say that scalability is synonymous with speed. Decentralization is where you have hundreds or even millions of unrelated computers around the world verifying and processing cryptocurrency transactions. If you're wondering why decentralization is important, I'll just show you this headline from 2018, when the 21 validators on EOS froze 7 wallets on its blockchain. Security is pretty self-explanatory. This includes stuff like a cryptocurrency's consensus mechanism and the encryption of its code. Now, to understand why you can't have all three, imagine that you have a cryptocurrency that can handle 1,000 transactions per second. This checks the box for scalability. Let's say this cryptocurrency also has 1,000 independently run computers connected to its network processing transactions. This checks the box for decentralization. And finally, let's assume this cryptocurrency has a proof-of-stake consensus mechanism that's super secure because it requires more than half of all the computers on the network to sign off on each transaction. On paper, therefore, you've overcome the blockchain trilemma, and this is what many cryptocurrencies have claimed to have done. However, things change very quickly when the rubber hits the road. Recall that our cryptocurrency has 1,000 computers connected to its network spread around the world. 501 of them must confirm a transaction for it to be valid as per the consensus mechanism. When the number of users and transactions is low, this isn't a problem. But as the number of users and transactions starts to grow, it's no longer possible to efficiently get 501 computers to check each transaction. For our fictional cryptocurrency network to remain operational, we have to either reduce the number of transactions per second the system can handle, reduce the number of computers connected to the network, or change the consensus mechanism so it requires fewer computers to confirm each transaction. If we choose the first option, we sacrifice scalability. If we choose the second, we sacrifice decentralization. And if we choose the third, then we sacrifice security. In the case of Bitcoin, creator Satoshi Nakamoto consciously decided to sacrifice scalability to ensure security and decentralization. Vitalik and the other Ethereum founders made the same trade-off at the outset, and Ethereum 2.0 will likely sacrifice decentralization to get the speed it needs to support its ecosystem. You'll see why later. Layer 2 solutions for Bitcoin, like the Lightning Network, are designed to enhance Bitcoin's scalability while leveraging the Bitcoin blockchain for security and decentralization. Layer 2 solutions for Ethereum, like Polygon, do the same with the Ethereum blockchain. Most high-performance cryptocurrencies have opted to sacrifice decentralization to become scalable, and this arguably applies to the Layer 2s I just mentioned as well. To use two quick examples, Polkadot currently has about 300 validators. This sounds decentralized at first, until you realize that each parachain running Polkadot smart contracts will only use 10 validators. Similarly, Polygon technically has 100 validators, but the Plasma chain, which actually runs the decentralized applications on Polygon, only has 7 to 10 nodes. Now, this brings me to an important point that is almost never raised when examining cryptocurrency transaction speeds, and that's that not all transactions are created equal. Transferring a coin or token from one wallet to another is not the same as executing a complex smart contract in a decentralized application like an Aave flash loan, for example. There are very few smart contract compatible cryptocurrencies that make a distinction between their smart contract transactions and regular transactions when advertising their transaction speeds. When you go digging through their documentation, you'll often find that smart contract transactions are significantly slower than regular transactions, assuming they list those figures at all. Moreover, many so-called Ethereum killers actually leverage a version of the Ethereum virtual machine, which is inherently limited to 300 transactions per second, even when running on a single computer. These are a few of the reasons why two of Cardano's top software engineers did a presentation last year titled, quote, Lies, Damned Lies, and TPS Benchmarks. In it, they explained that cryptocurrency transactions are more like packets of data than blips in a digital system. Cryptocurrency blockchains are basically like databases that process and store transaction data. For example, each block on the Bitcoin blockchain can hold 1 megabyte of data, which is 1 million bytes. The size of the average Bitcoin transaction is just under 400 bytes. When you do the maths, this means each Bitcoin block can fit between 2,500 and 2,700 transactions. Now, because one Bitcoin block is made every 10 minutes, this works out to about 5 transactions per second. The reason why Bitcoin's block size is so small and its block time so long has to do with security and decentralization. Every time a new block is created, this adds 1 megabyte of data to the Bitcoin blockchain, regardless of how many transactions are in the block. Don't ask me why, that's just how blockchains work. This means that over time, the size of the Bitcoin blockchain grows. Today, the Bitcoin blockchain is around 337 gigabytes in size. Every computer that joins the Bitcoin network needs to download this transaction history so it can know what's going on and process transactions correctly. While increasing Bitcoin's block size would mean each block could fit more transactions, it would also make Bitcoin's transaction history grow much faster. To use an extreme example, if each Bitcoin block were 1 gigabyte in size, it would be able to handle 5,000 transactions per second. However, the blockchain would grow so fast that only massive data centers would be able to store its transaction history, meaning only a few computers would be able to join the Bitcoin blockchain. Not only that, but every single one of these data centers would need to have the fastest fiber internet on the planet just to keep up with each new block being created. Similarly, if you accelerated Bitcoin's block time to 6 seconds, this would increase Bitcoin's transactions per second to 500. The problem here is that 6 seconds isn't nearly enough time for enough computers to check whether the transactions in that block are valid or not. This would result in Bitcoin's blockchain splitting into multiple different blockchains with conflicting transaction histories, which would effectively corrupt the network. Understanding that a cryptocurrency's speed is just its ability to process and store data makes it possible to calculate the real transaction speed of any cryptocurrency using a few metrics. All you need to know is how big each block is, how frequently a block is made, and how large the average transaction on that cryptocurrency's blockchain tends to be. This calculation is sometimes easier said than done because some cryptocurrencies will actually adapt their block size to accommodate transaction demand. One such cryptocurrency is Monero, which can have a TPS score as low as 4 and as high as 2,000 because of its elastic block technology. Ethereum has been gradually increasing its block size over the years for the same reason. Ethereum's TPS is 15 to 17, and that's because each block on Ethereum is 51,000 bytes. A new block is generated every 13 seconds, and the average Ethereum transaction, as of late, is around 2,500 bytes. Cardano's blockchain can handle roughly 200 transactions per second, and that can be mathed out from Cardano's block size of 2 megabytes, its block time of 20 seconds, and Cardano average transaction size of 500 bytes. Obviously, the reason why transactions on Ethereum are so much larger than those on Cardano is because Ethereum has smart contracts, whereas Cardano doesn't. Yet. Luckily for Cardano, smart contracts shouldn't clog up its blockchain because of its dual-chain architecture, which separates smart contract data and transaction data. Unfortunately for Cardano, a block size of 2 megabyte with a 20-second speed means that the size of its blockchain is growing fast, and that could become an issue for decentralization in a few years' time. Anyhow, the coolest part about this calculation is that it means the theoretical limit for how fast a cryptocurrency can be is fundamentally set by the speed of the internet around the world. According to speedtest.com, the average download speed is 100 megabytes per second, and the average upload speed is 50 megabytes per second. When you compare this to Ethereum's 2 kilobytes per second and Cardano's 10 kilobytes per second, it's clear that there's lots of legroom for cryptocurrencies to increase their speed. So, this begs the question, how fast is fast enough? The de facto benchmark for speed in the crypto space is Visa. This is because there are an estimated 4 billion Visa cardholders, which makes Visa's payment network a good template for future crypto adoption. While Visa's self-reported transactions per second is 65,000, Visa only processes around 2,000 transactions per second on any given day. The only existing cryptocurrency that comes close to this level of throughput is currently Solana, which can handle between 50 to 65,000 transactions per second, even for smart contract transactions. Now, although I haven't personally stress-tested Solana's scalability, FTX and Alameda research founder Sam Bankman-Fried has. Sam chose Solana to host FTX's project, Serum Dex, specifically because it was the fastest smart contract crypto on the market. As you can imagine, Solana has also had its fair share of network issues. This is because it had to compromise on security to have such fast speeds without running off a single computer. When you consider the fact that Solana transactions can be as large as 500 bytes, this also means the Solana blockchain is generating insane amounts of transaction history data every day. Although the Solana blockchain has only been live for little more than a year, that blockchain is already more than 2 terabytes large. To put things into context, this is more than twice the size of the blockchains of the top 10 cryptocurrencies combined. As I mentioned earlier, this seriously threatens its decentralization. Now, Solana's solution to this exponential growth is to outsource its data storage to a decentralized storage cryptocurrency project called Aave. Solana validators only keep the last 2 days of transaction data. Now, if you want to learn more about Solana, you can watch my most recent video about it using that link up there in the top right. If you think the crypto speed case is closed with Solana, I'm afraid you're mistaken. That's because transaction execution and transaction confirmation are 2 very different things. You've probably noticed that when you send your cryptocurrency to an exchange, there are a certain number of confirmations you need to wait for before the coins or tokens are credited to your account. Confirmations are basically the number of blocks that have been created since you made the transaction. The first block your transaction is included in is usually the first confirmation. And of course, every cryptocurrency has a different block time. For most exchanges, one confirmation is enough for them to credit your crypto, unless you're sending Ethereum Classic to Kraken, in which case you'll be waiting for 40,000 confirmations, which is about a week. This is because Ethereum Classic has been subject to multiple 51% attacks in the past, which is essentially when the network is manipulated by miners to credit cryptocurrency to their accounts. Cryptocurrency exchanges always want to make sure the transaction is final before they credit your account, and the likelihood that a transaction is final typically increases with each confirmation. For Bitcoin, the likelihood that a transaction is final is over 99.9% after 6 confirmations. Naturally, this needs to be much longer for less secure blockchains like Ethereum Classic. What's interesting is that even though Solana has a block time of 400 milliseconds, its transaction finality time is actually somewhat longer. This has to do with Solana's elaborate consensus mechanism. By contrast, there are multiple cryptocurrencies that offer instant transaction finality. These include Algorand, XRP, Stellar, Cosmos, and any blockchains that use the Tendermint consensus mechanism. Even though all these cryptocurrencies are slower than Solana in terms of TPS, exchanges can know for sure that transactions coming from them are final the moment they generate a block. That's why the deposit times for all of them on Kraken are noted as near instant, whereas a Solana deposit can take as long as 2 minutes on Binance. Now, not surprisingly, this is possible because all the cryptocurrencies I just mentioned are extremely centralized. They only have a dozen or so validator nodes processing transactions. While these finality thresholds aren't always needed for wallet-to-wallet or dApp transactions, it's likely that the crypto merchants of the future will use finality benchmarks similar to today's cryptocurrency exchanges. Now, if you want to learn all about the cool stuff you can buy with cryptocurrency right now, be sure to watch my video about that. It's hanging up there in the top right. There's only one category left in this crypto speed competition, and that is whether these transaction speeds actually make any difference to the end user. Whether a cryptocurrency is packing a 10K TPS engine or a 65K TPS engine under the hood is kind of irrelevant, and there's science to back up this claim. Decades of research in human factors engineering shows that any feedback a person gets from interacting with a computer within 0.1 seconds is perceived as instant. If the feedback comes within 1 second of the interaction, it's noticeable but not interpreted as a delay. Anything longer than 10 seconds is long enough for a person to get impatient and start doing other things while they wait. Attention spans these days, eh? Now, anyways, you've probably noticed that when you make a payment using a debit or credit card, it normally takes between 5 and 10 seconds to complete, even when it's an online payment. Many cryptocurrencies have block times that fall within this range, which would put their transaction speeds on a par with traditional payment systems for the average user, finality notwithstanding. You've probably also found that most wallet-to-wallet cryptocurrency transactions take roughly the same amount of time, assuming it's not Bitcoin, Ethereum, or an ERC20 token. This seems like a good thing at first glance, but it reveals just how many cryptocurrency projects are centralized and likely lacking security. Bitcoin and Ethereum are slow, but they are secure and decentralized because of that. I reckon it's why people are willing to pay such a premium in gas fees to move their funds on those networks. While Ethereum 2.0 will apparently increase its TPS score to 100,000, the things that we've explored in this video suggest that decentralization and security will need to be sacrificed to do that. To quickly recap, Ethereum 2.0 will feature sharding, which is when transaction histories and balances are split between multiple blockchains called shards. To preserve security, these shard chains connect to a central blockchain called the relay chain. As far as I understand, each shard on Ethereum 2.0 will only have around 128 validators at any given time. These will be pseudo-randomly selected based on how much ETH they are staking. That's pretty decentralized compared to other high-performance blockchains, but it's nowhere near as decentralized as Ethereum's current form. What's more is that communication and transactions between these shards will likely be limited, if not non-existent, at the outset. we would end up in a scenario where Ethereum 2.0 is essentially made up of 64 isolated blockchains with suboptimal security and decentralization. This is the same issue that Kusama and Polkadot are currently facing with their parachain slot auctions, and you can learn more about those by clicking that link up there in the top right. The massive increase in institutional adoption of cryptocurrency we've seen over the last year has put scalability in the spotlight, but it's left decentralization and security in the shade. I am aware that there are people much smarter than me who argue that the blockchain trilemma is just an imaginary problem, but try as I might, I don't see a solution to it. Whenever I find a cryptocurrency that's scalable, it's almost never decentralized and seldom secure. The cryptocurrencies that seem to be all three never provide the same performance for their smart contract transactions. Now that said, I really think Cardano has the right approach when it comes to addressing scalability. Embracing the notion that cryptocurrencies are just distributed computing systems akin to the internet helps identify what the scalability problem really is, and this makes solutions easier to find. Solana founder Anatoly Yakovenko seems to be hyper-aware of this, and Solana's decision to delegate its data storage is evidence to my observation. Solana's only real bottleneck seems to be data storage, and that's something that can be easily addressed as data storage becomes easier and more cost-efficient inside and outside of cryptocurrency. When you combine access to data with faster internet speeds, it suddenly becomes possible to have blockchains that are in fact scalable, decentralized, and secure. This seems to be the kind of future we're heading towards, but every so often I see something that makes me wonder if we're headed in the opposite direction. Many of these centralized high-performance blockchains have become prime candidates for central bank digital currencies, namely Algorand and Stellar. It seems that governments have the same end-user approach in their development of CBDCs, health passports, and other borderline dystopian technologies. The technologies probably won't be very secure, and they definitely won't be decentralized. But because they're scalable, the end user probably isn't going to care so long as it works for them. That is a scary thought, but the bright side is that most cryptocurrencies are already capable of throughput that's comparable to existing systems for the average person. For me personally, I've found that Polkadot transactions are insanely fast, regardless if I'm sending DOT to, from, or between exchanges. I could swear I've seen some arrive within 5 seconds, which is obviously impossible given that Polkadot's block time is 6 seconds. All that's really missing is awareness, education, and user interfaces for applications that don't look like they come from the inside of a SpaceX shuttle. This trifecta poses even bigger problems than the scalability trilemma at this point, and that is why I'm here. If you enjoyed today's video, you know the drill. Hit that like button, smash that subscribe button, and ping that notification bell to give me a thrill. If you want to get more from the Coin Bureau, you can follow me on Twitter, TikTok, Instagram, and join my free Telegram channel for daily crypto market updates. If you want to get a sneak peek of which topics I'll be tackling next, subscribing to my weekly newsletter is the way to do it best. Last but not least, you can support the channel by getting some sweet crypto merch from the Coin Bureau merch store. That includes this epic HODL hoodie line. If that's news to you, head on over to the video description and follow the links to my socials, Telegram, and weekly newsletter. Thank you so much, as always, for watching. Stay cool, Crypto Cats.